Namaste and welcome back to JEE Chemistry with Typical Monk. This is Class 30, Organic Chemistry, Part 5, the alkyl halides. Take a carbon, attach a halogen, and you have made one of the most useful molecules in all of organic chemistry. That single polar bond, carbon slightly positive, halogen slightly negative, turns the carbon into an open door. Nucleophiles walk in, the halide walks out, and a whole family of products appears. From it flow alcohols and amines, nitriles and alkenes, and the mighty Grignard reagent that builds carbon chains. Today, the polar bond, the ways to make an alkyl halide, and the named reactions every exam loves. One idea at a time. Here is what you will master today. First, classification and nomenclature. Second, the methods of preparation. Third, the polar carbon-halogen bond and the properties. Fourth, substitution and elimination. And fifth, the named reactions, one idea at a time. Let us set the foundation. An alkyl halide. It is a halogen atom bonded to an sp3 carbon, written R-X. Classification, primary, secondary, or tertiary, and mono, D, or polyhalide. The polar bond. The carbon-halogen bond is polar, which makes the carbon electrophilic. Master line, the alkyl halide is the workhorse of organic synthesis. Now look at the picture. The polar carbon-halogen bond. The polar bond. The carbon-halogen bond is polar. The carbon carries a partial positive charge, the halogen a partial negative. The electrophilic carbon, that partial positive carbon, is exactly the point a nucleophile attacks. The leaving group. The halogen departs as a stable halide ion. Reactivity. The carbon-iodine bond is the weakest, so R-iodide is the most reactive and R-fluoride the least. Now, how we make an alkyl halide. From alcohols, react with a hydrogen halide or with phosphorus trichloride, phosphorus pentachloride, or thionyl chloride. From alkenes, add a hydrogen halide by Markovnikov's rule or add a halogen across the double bond. From alkanes, free radical halogenation in sunlight, though this gives a mixture. Halide exchange, Finkelstein makes the iodides and Schwarz makes the fluorides. Now, the reactions, substitution and elimination. Nucleophilic substitution. By SN or SN2, a nucleophile replaces the halide with potassium hydroxide. Aqueous potassium hydroxide gives an alcohol, but alcoholic potassium hydroxide gives an alkene by elimination. With cyanides, potassium cyanide gives a nitrile, carbon bonded, silver cyanide gives an isocyanide, nitrogen bonded. Others, ammonia gives an amine, and silver nitrite gives a nitrile cane. Reactivity, R minus iodide over R minus bromide over R minus chloride, and for SN1, the tertiary is fastest. Now look at the picture, the named reactions, all around R minus X. Words with sodium in dry ether, two alkyl halides couple into an alkyne. Finkelstein. With sodium iodide in acetone, R minus chloride or R minus bromide becomes R minus iodide. Schwarz. With a metal fluoride, like silver fluoride, an alkyl halide becomes an alkyl fluoride. Grignard. With magnesium in dry ether, R minus X becomes the Grignard reagent, R minus magnesium minus X. Now a few more reactions worth marks. Words. Two molecules of R minus X with sodium give a higher symmetrical alkane. Grignard, R minus X with magnesium in dry ether, the great chain building tool of organic chemistry. Grignard care. It reacts violently with even a trace of water, so everything must be perfectly dry. Reduction. R minus X is reduced to an alkane, for example with zinc and acid. Friedel crafts. R minus X alkylates benzene in the presence of anhydrous aluminium chloride. Now the physical picture. Polarity. Alkyl halides are polar and yet they are insoluble in water. Boiling point. It rises with the molecular size and also down the halogen group. Density. The bromides and the iodides are denser than water. Now match each reagent to its named reaction. Sodium in dry ether goes to the Wurtz reaction. Sodium iodide in acetone goes to the Finkelstein reaction. Silver fluoride goes to the Schwarz reaction. And magnesium in dry ether goes to the Grignard reaction. 4 pairs, each worth memorizing. Now, how many of these statements are correct? Statement 1. R- iodide is more reactive than R- chloride. Correct. Statement 2. The carbon-halogen bond is non-polar. Wrong, it is polar. Statement 3. Alcoholic potassium hydroxide gives an alkene. Correct. So the answer, 2 are correct. Statements 1 and 3. The trap is the carbon-halogen bond in statement 2. Now, the 2 mistakes that quietly cost marks. The truth. Aqueous potassium hydroxide gives an alcohol by substitution, while alcoholic potassium hydroxide gives an alkene by elimination. The trap, swapping the aqueous and the alcoholic potash. The second truth. Potassium cyanide gives a nitrile, carbon-bonded. Silver cyanide gives an isocyanide, nitrogen-bonded. The second trap. Forgetting the reactivity order, R- iodide, over bromide, over chloride, over fluoride. Now test yourself. Answer in your head before the reveal. That is how G-speed is built. Here we go. Question 1. The most reactive alkyl halide? R- iodide. Question 2. Aqueous potassium hydroxide gives an alcohol. Question 3. Alcoholic potassium hydroxide gives an alkene. Question 4. The Grignard reagent R- magnesium minus X. And question 5. Sodium iodide in acetone is the Finkelstein reaction. Let us gather it all in one breath. An alkyl halide, a halogen on an sp3 carbon, a polar carbon-halogen bond, prepared from alcohols, alkenes, and alkanes. Reaction: nucleophilic substitution and elimination. The named reactions: Wurtz, Finkelstein, Schwarz, and Grignard. Reactivity: R- iodide over bromide, over chloride, over fluoride. Next class: alcohols, phenols, and ethers. One bond, many doors. The alkyl halide earns its place at the center of organic chemistry through a single cooperative bond, because the carbon carries a partial positive charge and the halogen a partial negative. The molecule welcomes attack. Swap the halide for hydroxide, cyanide, ammonia, or a magnesium atom, and out come alcohols, nitriles, amines, and Grignard reagents. Remember which reagent opens which door. Aqueous versus alcoholic potash, Wurtz versus Finkelstein versus Schwarz, and the reactivity that always favors the iodide. Master these, and you can build almost anything. Next class: alcohols, phenols, and ethers. Sarah, David, Lisa, and John all began exactly where you are sitting now. One idea at a time, you will crack G. I will see you in the next class.